English with Astronomy, Episode 11.
The second episode is called The Giant Planets. Beyond Mars's orbit begins the realm of very different worlds. 4 colossal planets, Jupiter, Saturn, Uranus, and Neptune, stand in sharp contrast to their rocky cousins. These are gas and ice giants, huge spheres made mostly of light elements. They have no solid surface to step on. Any craft would sink into deepening atmosphere until pressure crushed it. All 4 giants share vast size and a broadly similar interior makeup. They have powerful hydrogen-helium atmospheres and rotate quickly, whipping up fierce winds and storms. Each owns rings and whole families of moons, miniature planetary systems. Yet each giant is unique and full of puzzles. Jupiter, the 5th planet, is the system's undisputed ruler. Its mass is about 300 Earths, its volume about 1,300. Named for the king of the gods, it spins in roughly 10 hours, so fast that the globe is slightly squashed at the poles. Jupiter's atmosphere is a raging ocean of gas. The Great Red Spot, an Earth-sized storm, has been watched for over 3 centuries. Cloud bands wrap the planet as bright zones and dark belts. Deep below, hydrogen is squeezed into liquid metal, feeding a colossal magnetic field. Jupiter swarms with moons. Galileo saw the 4 big ones with his small telescope. Io spews sulfur from volcanoes. Europa hides an ice shell and likely a global ocean. Ganymede is the largest moon in the solar system, bigger than Mercury. Callisto is ancient and crater-scarred. Jupiter also has rings, thin, dark, and hard to spot. Saturn, the 6th planet and second largest giant, is famous for its magnificent rings. Despite its size, it's surprisingly light. Its average density is less than water's. Saturn's rings look solid from afar, but they're billions of icy pieces, from dust grains to house-sized blocks, orbiting together. They span hundreds of thousands of kilometers, yet are astonishingly thin, sometimes only tens of meters. Gaps divide them. The Cassini Division is wide enough to see in a small telescope. Saturn has over 100 known moons. Titan carries a thick atmosphere and lakes of liquid methane and ethane. Enceladus jets water vapor from a subsurface ocean. Some think life might be possible there. Uranus, the 7th planet, was the first found by telescope. It's an oddball. Its axis is tipped by almost 90 degrees, as if knocked on its side. That tilt brings strange seasons, about 42 years of day followed by roughly 42 years of night at each pole. Uranus is an ice giant, richer in water, methane, and ammonia ices than in hydrogen and helium. Methane tints it blue-green. Upper atmosphere temperatures can drop near -200 Celsius. Its rings are narrow and dark, and it hosts over 24 moons with names from Shakespeare and Pope. Neptune, the 8th planet, is farthest from the Sun. It was predicted mathematically when Uranus's motion didn't add up. Then, telescopes found it where the math pointed. Named for the sea god, it shines a vivid blue, likely thanks to atmospheric methane. Neptune is slightly smaller than Uranus, but more massive and far more active. Its winds are the fastest in the solar system, up to about 2,000 kilometers per hour. A great dark spot appeared late last century, faded, and new dark storms have come and gone. Among its many moons, Triton stands out, orbiting backwards and slowly spiraling inward. In the distant future, gravity may tear it apart, forming a bright ring system to rival Saturn's. The giant planets formed in the cold outer reaches, where light materials could condense and pile up. They became lords of the outskirts, each with rings, moons, and mysteries, worlds humanity is only beginning to understand. That's our story about the second family of planets. Let's hear your questions.
Thanks, Susie, for another insightful tour. Here are my questions. First, how do the giant planets differ from the terrestrial planets? Second, how does Jupiter's rapid rotation affect its shape? Third, what are Saturn's rings made of? Fourth, why does Uranus experience such long nights? Fifth, what is Neptune's largest moon called, and what makes it interesting? And now, my recap. Beyond Mars, the scale steps up. 4 giants: Jupiter, Saturn, Uranus, Neptune. No solid ground, just deep atmospheres of hydrogen, helium, and isis. They spin fast, whip up jet streams and monster storms, and every one of them wears rings and commands a crowd of moons, mini solar systems in their own right. Jupiter first, the heavyweight champ. It turns in about 10 hours, wrapped in dark and light bands and the legendary Great Red Spot. Go deep enough, and hydrogen turns metallic, creating a huge magnetic field that, in radio waves, looks bigger than the Sun. Its big four, Io, volcanic fire; Europa, an ice shell over an ocean; Ganymede, the largest moon with its own magnetic field; and Callisto, ancient craters, are a solar system sampler. Jupiter even has faint, dusty rings. Saturn is the elegant one. Slightly smaller, so light on average it would float in a very large tub. Those rings? Wide as a planet, razor thin, carved with gaps like the Cassini Division. The moon's steel scenes. Titan with thick orange skies and methane lakes. Enceladus spraying water ice geysers from a hidden ocean. Uranus arrives as the first telescopic find, an ice giant tipped on its side by about 90 degrees. That tilt turns its poles into extreme theaters, roughly 42 years of daylight, then 42 of night. Methane gives the globe a cool blue-green tint. It sports narrow, dark rings and a troupe of moons with Shakespearean names. Neptune is the one mathematics predicted before the telescope confirmed it. Deeper blue, more restless, home to the fastest winds in the solar system and shifting dark spots that come and go. Triton, its largest moon, orbits backward, likely a captured wanderer that may one day be torn into rings. All 4 grew in the cold outer nebula, snagging gas and ices and becoming the lords of the outskirts. Their rich moon systems and active atmospheres keep surprising us, proof that the solar system still has chapters left to read.
Thanks, Jim. Let's keep moving.